So our counter component is working nicely. But before we go on to the next example, we have to discuss a very important topic related to the reducer function. And so to discuss the topic, let us go back to our first example's code, which is the counter reducer. As you can see here, on the left, we have the counter component, counter.js. And on the right, we have the counter reducer.js file, which contains the reducer function. And the topic that we are going to discuss regarding the reducer function is related to what we return from the reducer function. As you can see here, we are returning an object like this. If you observe closely, what we are doing here is actually we are creating a new object and then returning that object. Let's rewrite this line of code to indicate that more clearly. So I'm going to duplicate this line and I'm going to comment out the original line. And now in this new line of code, let's remove this return keyword over here and assign this object to a variable called new state like this. And let us return new state like this. So we have written this line of code more explicitly as these two lines of code. And if we examine this code, what we are doing is we are taking this state object and then creating a new object out of it, and that we are assigning to a variable called new state, and then we are returning the new state variable. Let me remove this commented out line over here so that the code is more clear. And some of you or most of you must be wondering why we needed to create a new object just to increment the value by 1. We could have very well have written the code like this: state dot value plus equal to 1 like this, and we could have returned state like this. And so the question is, why did we not do this? And the short answer to that is because this will not work. But the real question is, why will it not work? Let's look at what will happen if we write the code like this and really understand the root cause of why this code will not work. So I'm going to save the file and I'm going to the web page now. Let me refresh the page and I'll select the state tab once again so that we can see our state tree over here. And I request you to keep an eye on this value over here and also compare it with this value over here. I'm going to click on this plus button over here now. And as you can see here, this value over here has changed to 1, but that is not getting reflected over here because 0 is still being displayed over here. I'm going to click on this plus button again. And as you can see here, this value has changed to 2. It got incremented to 2. You can see the increment actions over here. So it looks like as I am clicking on these buttons over here, the value in the Redux store, in the Redux state tree is changing, but that change is not being detected for some reason, which is causing React to not update the value in the UI. So I'm going to click on this button a few more times and you can see that this value is changing over here in the state tree, but that value is not ultimately getting reflected in the UI by React. And to understand the reason why this is happening, we have to discuss about JavaScript primitive types versus non-primitive types and how the operations of assignment and equality check are different for them. Before we start that discussion, let me quickly discuss what I have done over here. In the code that was working, we had created a new object and then we had returned that new object. To create that new object, we made use of the existing state object and that was working earlier. Then we commented out that code, and what we have now done is we have proceeded to modify the state object that was passed to the reducer. As you can see here, this statement over here, we are directly modifying the state object that has been passed to the reducer, because you can see that state is appearing on the left hand side of the assignment operation over here. And in the next line of code, we are returning that state object. And this did not work in the sense that although the value was getting incremented within the state tree, the changes were not being applied to the UI by React over here. And so we are going to discuss the root cause of why that is happening. And the root cause is related to how primitive types in JavaScript like numbers, strings are different from non-primitive types like objects and arrays. So let's discuss in detail about the differences. So examples of primitive types in JavaScript are numbers, strings, etc. And operations on primitive types are done by value. So what do we mean by that? That means primitive types are copied by value and the equality check on primitive types are also done by value. Let's look at an example. So here we have the code n equal to 0. That means the variable n is being assigned the value 0. And if we were to illustrate how this looks in the memory, then it would look like this. We have the variable n over here, which is pointing to the value 0 in memory. And now let us discuss about non-primitive types. Examples of non-primitive types are arrays, objects, and how they are different is that the operations are done by reference. That means copy is done by reference, and also the equality checks are done by reference. Again, what do we mean by that? Let's look at an example. Here we have an object which has the key value pair a:1, and if we were to illustrate how this looks in the memory, it will look like this. So the variable obj is the obj over here, and this key value pair a:1 is in this memory location over here. But as you can see here, between obj and the actual a:1 key value pair, we have this over here. And this memory location will actually store the memory address or the reference of the actual object over here. And the variable obj will actually just point to the memory address or the reference, which in turn points to the actual object over here. So let me repeat that once again. The variable obj will point to the memory address or reference, which actually points to the actual memory location of the object. And this is the same for arrays as well. So for primitive types, the variable was directly pointing to the actual value, but for non-primitive types, the variable actually points to the reference, which then points to the actual value. And this difference has significant implications, and amongst them are how the assignment and equality check operators work. The equals operator over here, which is the assignment operator, and the equality check operator over here, which is the double equal to or triple equal to operator, they work differently for primitive types versus reference types. Let me mention that once again. The assignment operator and the equality check operator, they work differently for primitive types versus reference types. Let's first discuss about how the assignment operation is different. Here we have an assignment statement. Actually, it is two assignment statements written on one line. So m equals n equals 0. So we are talking about primitive types here because 0 is a primitive type, an integer. So first n equal to 0 will be executed. And so in the memory, this is what it will look like. The variable n will be pointing to the value 0. And then m will be assigned the value of n, which will be 0 by that point. And when this is executed, this is what it will look like in the memory. M will point to a new location in the memory which contains the value 0. And this is what I meant by copy by value. So the point to note here is that in the memory, M and N each have their own value of 0, like this. Now let us see how a similar assignment operation will work with non-primitive types. Here we have the statement obj2 equals obj equals an object a:1. So this is an object with the key value pair a and 1. When this line of code is executed, first this part that I have underlined here is what gets executed. So obj is assigned the object a:1. But in the memory, how it will look is like this over here. Like we have previously discussed, obj will point to the reference, which will then point to the actual object. And next, this assignment is executed, obj2 equal to obj. And we have to note that obj is pointing to the reference over here. And so obj2 also will be assigned the reference. So obj2 also will end up pointing to the same reference. Let's discuss that once again. This object over here will be stored in a memory location. Let's say the memory location is x. What obj and obj2 will have as their value is they will have the value of x. Basically, they will have the reference to where the actual object is stored in the memory. So for primitive types, when variables are assigned like this, each of the variables end up getting a copy of the value. So in the memory, there will be separate copies of the value, but when it comes to arrays and objects, the values that are assigned to the variables are references to the objects or arrays. So when an assignment like this is done, what will effectively happen is that both of the variables will point to the same memory reference, which will then point to the actual object or array. So this is how the assignment operation is different for primitive types and non-primitive types. Now let's discuss how the equality check is different for primitive types and non-primitive types. So we have these two lines of code. In the top line, we have the primitive type 0, and in the bottom line, we have the object a:1, and we are assigning them to a couple of variables. So what happens when we modify the value of m? And let us also discuss what happens when we modify the value of obj2. So let's talk about modifying primitive types first. So here we have m equal to n equal to 0, and in the memory it will look like this: n points to 0 and m points to 0. And so what happens when we modify m? Let's say we modify m like this: m plus equals 1. So we want to increment m by 1, and when we do that, m's value will change from 0 to 1 like this. And at this point, if we were to compare m and n, you can clearly see that m is not equal to n, because m's value is 1 and n's value is 0. So the equality check will return the value false, meaning m will not be equal to n. Now let us discuss a similar example for non-primitive types or reference types. So here we have the statement obj2 equal to obj equals a:1, which is an object. So what happens if we modify this variable obj2? Let's say we increment the value of the key within obj2 like this: obj2.a plus equals 1. So when the statement executes, what will happen is this object over here will change from a:1 to a:2. At this point, if we were to compare the variables obj and obj2 using the equality operator, you can see here that obj and obj2 actually point to the reference, which then points to the object. So the equality check will return true, because in reality there is only one copy of the object, although there are two variables. Let's discuss this one more time. For primitive types, since each of the variables have their own copies of the values, modifying one will not affect the other. But when it comes to arrays or objects or other reference types, variables that were created using the assignment operator, similar to statements like this, will actually have only one copy of the object or array in the memory. And both of the variables will point to the reference, which will then point to the actual object in memory. And hence, modifying the actual object in memory will have the effect of modifying all of the variables that point to the reference of that object. So why is this important in the context of Redux? And this is important because of how Redux finds out if the state has changed or not. So how does Redux find out if the state has changed or not? Meaning when the user clicks on buttons which raise actions which are then handled by the reducer, which changes the state, how does Redux find out if the state has changed or not? And Redux uses the equality operator that we have been discussing to detect changes. So the reducer returns new state. As you can see, the job of the reducer is to take in the current state and an action, and it has to return the new state. That's why we have all these return statements for each of these cases over here. So the job of the reducer is to return the new state. So the reducer returns the new state, and Redux checks if the new state is equal to the previous state or not. And it does that by using the equality operator over here. Let me mention that quickly once again. So reducer returns the new state, and Redux checks if the new state is equal to the previous state using the equality operator that we have been discussing. And depending on whether the state is a primitive type like integer, strings, etc., or a non-primitive type like arrays or objects, this equality check over here will be different, like we have been discussing earlier. And so if we come back to the code over here, the incoming variable is state. So this state will point to a reference. And if we modify the contents of the state variable like this, yes, the contents will get updated. But when we return the same reference, what will happen is Redux will not know that the state has changed. Because in this example, state is an object. And when objects are compared, Redux only compares the references and not the actual contents of the object. So if the references are the same, Redux will not know that the value has changed, and hence it will not inform React that the value has changed and hence the UI will not get updated. And so in the state tree over here, we have an object, and although this object is changing over here, because of the way the equality check is done by Redux, Redux only compares the reference that the reducer returns with the current reference that it has. And so if the reducer returns the same reference that was passed to it, then that means that Redux will not be able to tell if something has changed or not. And that is the reason why this value over here is not being reflected over here. And that is the reason this code is not working. So let's comment out this code now, and let's uncomment our previous code. And now we are back to creating a new object. And since a new object will have a new reference, this variable new state over here will be assigned the new reference of this new object over here. And if we return that new reference from the reducer, then Redux will be able to tell that this new reference is different from the old reference, and hence it will inform React. So let's check if our code is working once again. So I'm going to refresh the page, and I'm going to select state over here, and I'm going to click on this plus button now. And you can see that clicking the plus button is incrementing the value over here. And once this value gets incremented, it in turn is being reflected over here. You can see that the value is 4 over here and 4 over here as well. Since this is a very important requirement of the reducer function, the creators of Redux have communicated that requirement as follows. They have put the restriction that a reducer function must be pure. Let me mention that once again. In Redux, the reducer functions must be pure. That is, if we want to avoid problems like the problem we discussed earlier. If we go to Wikipedia, it mentions that a pure function is a function that has the following properties, and one of its properties is that the function application has no side effects, and amongst the side effects, mutable reference arguments is listed. Let's read this once again. Pure function is a function which should not have side effects like changing reference arguments. The word mutation means changing, so it says that a pure function should not mutate. That means it should not change reference arguments. And in our counter example over here, our state is an object and it is being passed by Redux into the reducer over here. Since object is a reference type, we can say that this is a mutable reference argument. So the whole requirement of making sure to create new references and returning them has been conveyed by the restriction that a reducer must be a pure function. And that is why when we discuss about Redux or read about Redux, we will hear the terms pure function, mutation a lot. But like we have discussed earlier, the root cause is because of how primitive types are different from non-primitive types or reference types, and how they are handled in the memory by JavaScript, which then leads to different behavior in how they are assigned, as well as how the equality check happens for them. So now I think you will have a solid understanding of why Redux places this requirement of a reducer being a pure function. Next, we will discuss some techniques to help us create new objects and new arrays from existing objects and existing arrays, since that seems to be a very important requirement in Redux. And if that feels new or difficult, we also have an option to use a library called Immer to help make our lives a lot easier in that aspect. So we will discuss that in the next video.